Right. Okay. So I'd just like to introduce Chris Brignell, who's going to talk about higher education transitions, mathematics transitions to HE. Okay. Take it away, please, Chris.
Cheers, thanks, Kevin. Yeah, and I'm co-presenting this with my colleague Katie, if Katie wants to say hello.
Hello, everyone.
So we're going to do this as a double act. We'll pass it backwards and forwards between the two of us. Yeah, so what we're going to talk about today is some work we've been doing on the transitions into studying maths in higher education. So the plan is to kind of tell you a little bit about the observatory where we work. So just because we haven't done a Talmud talk before, I thought it might be useful for you to hear a little bit more about what we do. Then we're going to talk about the challenges for transitions into HE. We've done some data collection over the last 6 months to a year, so we're going to talk through some of the results of that, and then hopefully come to some conclusions. There'll be an opportunity as well, a couple of places during the talk where we'd like to really hear your thoughts and views. Yeah, we'd like to get your input as well. So let's start off with just a very quick introduction to what we do at the observatory. What is the Observatory for Mathematical Education? It's fairly new. We've been around for about 18 months now. We conduct research into the maths education system as a whole. So we don't do much on kind of pedagogic practice or assessment practice, but we're thinking about the system as a whole and how we can influence, hopefully, policy to improve the maths education system from primary schools, secondary schools, post-16, and obviously into university and postgraduate degrees as well. So yeah, we're very much wanting to make the maths education system better for everyone, both future fields medalists and those who don't go beyond GCSE. How do we do that? So there are kind of three strands to what we do. The first is trend analysis. So this is using data from the Office of National Statistics. So we have the kind of the education and kind of earnings records for around about, I think it's about 30 million individuals in England over the past 20 years. So we can see how educational attainment and progression in maths is dependent on things like social background or where they live or what education experiences they've had and so on, which education settings they've been in and so on. So we can see whether there are patterns in who progresses in maths and who does well and who doesn't, and try and pinpoint where in the system things are going wrong. So kind of in a university context, we might want to answer questions about what's associated with improved retention. If you move away to go to university versus commuting from home, does that have any impact? Or if you do A-level maths or either level 3 maths qualifications, does that help with studying maths degrees, or does it help with studying other subjects as well? So that's what we do with our kind of our ONS data. The other thing we do is we do longitudinal cohort studies. So we've currently got around about 8,000 primary school pupils who we are surveying every year for the next 7 years. They're currently in the reception year. We'll follow them all the way through to year 6. And we've got about 28,000 secondary school pupils. So we're surveying them every year from year 7 maths lessons all the way through to year 11 or year 13, depending on how far they go. For the purposes of this talk, we're also looking at year 12 students at the moment, and we're going to be following them through into year 13 and then into the university program. So these are year 12 pupils who are studying maths. And my colleague Stephen, who's on the call as well, can write in the chat how many pupils in year 12 we've got data for. But the idea is by surveying them every year, we can find out more about their attitudes to maths at every point in the system. And we also can talk to their teachers about how they're taught and try and link together what teachers are doing in the classroom through to what it means in terms of outcomes. Okay, so Stephen says we've got 8,000 A-level pupils, which is just under 10% of all A-level pupils in England. And the model that we're following for our longitudinal cohort studies is one where we're obviously trying to track attainment and participation as a kind of the things we're trying to measure. But we're trying to see how those are measured by kind of the individual, the classroom, the institution, so school or university, or the wider policy system that governs how our education system works. And of course, all of that is then embedded within all kinds of socio-cultural and familial factors in which the education system sits. So we're trying to make head or tail of all of these different things, lots of different scales going from an individual all the way up to national policy decisions and everything in between. I guess the third thing we do is kind of bespoke bits of work, looking at kind of evaluating our kind of interventions in the system. So as an example, one of the pieces of what we're doing at the moment is looking at specialist 16 to 18 maths schools and seeing whether or not they have a positive impact on the education system. So that's kind of a whistle-stop tour about what we do at the Observatory. If you've got any questions about that, I see there's a link to the Observatory's website in the chat. So thank you to whoever posted that. Feel free to click on that and have an explore around there and see what we do if you're interested in that. Right, I shall pass over to Katie.
Yes, so I'm going to be talking about some of the current challenges for the transition to higher education, because then we'll go on to the survey, which is what the focus is on. So next slide, Chris.
Cool. I've got to pay attention, haven't I?
So there's obviously challenges just around recruitment. So from A-level, or not everyone does A-levels, the other qualifications, from that to then doing a mathematical sciences degree. So this piece of work focuses on mathematical sciences, which we defined as anything that was 50% or more maths at university. So yeah, there's all the challenges of recruitment. So there's the different entry criteria that a student will come to university with, and the different criteria different universities have, which we know can vary massively across institutions. There's still this perception of maths as an elite subject, so it can put people off that would be perfectly qualified to apply and would more than likely be successful, but then perhaps aren't looking to do that degree, perhaps because of this sort of elite subject idea. Again, there's this perception, although I think people that work in higher education maybe will have the opposite perception, but are all maths degrees the same? Possibly not, possibly they actually differ massively between the different institutions. So that's, again, something for students as they're recruiting to consider. There's all differences at performance at those pre-qualification levels. So for example, male students outperform females at A-level. So again, that's going to affect recruitment of who is then applying to do the undergraduate degrees. And again, anyone that teaches will be able to, I imagine, look around and see the differences in a classroom of different demographics, and there's definitely a bias towards certain groups. And yeah, this retention is biased. So for example, high income and white students are two examples of that. And also there's whole issues around further maths. So not everyone has it, but it's not necessarily a disadvantage if you do a maths degree without it. Again, it's dependent on the institution. But it's sometimes seen as a real disadvantage when in actual fact often it maybe isn't, and again shouldn't put someone off applying to do a maths degree. We've then got the challenges around the transition. So once we've sort of got the recruitment, the students have applied, we then need to make sure that transition is successful, and that's really what this piece of work was looking at. So it's students that have already applied to do a mathematical sciences degree and looking at how they found that transition. So just in the chat, if people give maybe just a minute, think about what are the major issues that you see in transitions from learning mathematics at school, college to then learning at university. So yeah, it'd be interesting to hear what other people think those problems are, or if they've experienced any. So yeah, please do type it in the chat if you've got any thoughts. Yeah, so we've got lack of understanding of the different types of math degree. Yeah, so again, I think people can go in with very different ideas. Yeah, okay, there's lots coming in now. So I see the proof in twice. So yeah, that's one that always comes up and is one of the first ones to come up for me as well. That then this is something that they're not doing a lot at school, whereas when you get to university mathematics, there's suddenly a lot of proofs. Yeah, more independence. It's more abstract. Yeah, lack of confidence. It's good when these all align with what you're thinking. Chris, do shout if there's any that you see that you think are particularly interesting. I won't read them all out because I'll take up the whole talk.
Yeah, it's interesting one there about technology and different prior knowledge about technology that comes up in what we're about to say as well, I think.
Yeah.
As well as resilience, yeah.
Yeah. Yeah, I think, yeah, there's lots that we'll hopefully touch on, and then lots that, again, I mean, there's a range of issues that some that we've sort of picked up, and I'm sure that there's lots more that we'll still be able to carry on doing this work on and looking at. So if you have the next slide, please. So these were just some of the issues that we thought about, and I think a lot of these are kind of captured in what we've said. So I mean, there's, on the big picture, obviously from school there's 100,000 plus students, whereas at university there's less than 10,000 students that are doing maths. So there's just a difference in the amount of people that are doing the same thing. And then really, I guess importantly, is that we've got these national qualifications pre-university, whereas now we're going to institutional qualifications. So that fits with what someone said about the differences between different kinds of math degrees. Those qualifications can differ massively, whereas pre that at school, it's much more standardized. There's lots of differences just in how we learn. So at school, you've got textbooks, whereas at university, you can have all different resources, and they're very specific on the module or the lecturer. So one lecturer could teach the same module in a completely different way to a different lecturer. It's less classroom teaching, and you've got lectures and potentially some tutorials. The assessment might change, so there's a more variety often at university. So you have the courseworks, group projects, presentations, as well as exams, whereas students potentially are mainly used to, for maths, they do an exam. I think people said, again, abstract maths, whereas pre-university, it's more sort of concrete, the ideas, and perhaps less abstract. Again, I saw somebody had put the maths as more formal, and that's something I always see when I talk to my first year tutees. They actually know a lot of the maths, they just don't know how to write it in that formal sense. You've obviously as well got just the transition to university that's not sort of just maths specific, and they're living independently, they might have moved away. For people, at least in England, you've got tuition fees normally, whereas pre that, it was, for most people, will have been free education. And also your teacher, the role of the teacher sort of changes from a supporter to actually there's somebody that is examining you now, which will have an effect. So like I say, this is by no means a comprehensive list, and I think a lot of people captured similar ideas, but there's also lots of other really interesting ones that after I spoke, I'll probably read through all of these as well. But yeah, lots of challenges, and that's really what we wanted to do, is to sort of understand these challenges and see how they affect people within the transition and different groups of people. So I think next slide, please. So we did 2 surveys. So the first one ran the previous September, so September 2024. We got from UCAS a list of everyone enrolled on what we defined as a mathematical sciences degree, and sent them an email with the link to our survey. So it went to just under 7,000 new math students. So they got a concrete offer to study a maths degree, but it was before they'd started their maths degree. Just over 1,000 students replied, so it was a really good sample from 65 UK universities. And we did look at the sample, and it did seem representative of certain characteristics like gender, ethnicity. So again, we thought it was a sensible sample to work with. We then got back in touch with the students in February, so after they'd done around 6 months of their degree, and sent them a follow-up survey, and we got 758 responses. So we maintained a large amount of our first set. And this survey was open to anyone who had agreed. So students that had dropped out were still invited to take part in the survey, although they got a slightly different set of questions. So it meant that we really did capture all the different avenues that students had gone down, so we could see what was happening pre-university and then 6 months into university. And we're going to publish a report with all of our findings that we're going to go through very quickly, but of course, we can't go through them all in today's session. So if you'd like to read that report, I've got a QR code and I will send a link once I finish speaking in the chat for you to sign up to receive an email to get that report when it comes out the end of May or early June. And then, yes, so our survey, which we'll get onto the results in a second. We had a lot of questions, a lot of Likert scale questions. So things like how confident were they, what helps them learn maths, their experiences, behaviour regarding learning maths, and what they think about maths. And most of these were identical questions in the first and second survey. So again, it allowed us to see the change in students' responses pre-university and then 6 months in. So for example, we could see how their confidence had changed. We also asked questions on their demographics. So again, we could see how students, their ideas had changed based on different characteristics. So we had things like gender. All of these were self-reported. And we also only captured male, female, and other, we didn't go into more detail just because of the small enough sample size that it would have got too small to report any more numbers. We got income quartiles, the university they were going to, which we then classified by the grade requirement to get in, and then their expected first year grade. So again, that's a self-reported one that we asked them in the second survey. We asked them what they were expecting, which we've used, but obviously there's a caveat of that this is their self-reported, so we don't know if, for example, if someone has low confidence, they may well say they're going to get a lower grade than they actually would, or vice versa. But it still is useful for us to kind of see what they're expecting and how that varies with the responses. So I think I'm now handing over to Chris to start off some of the survey results.
Cool. Thanks, Katie. Nice story in the chat there from Tony. So congratulations to your PhD student. If you're able to share what made the difference to that student from potentially dropping out to continuing, that would be useful to hear. Right. So here are some of our results. So first of all, we kind of asked them about their confidence in mathematics. So the top bar here is showing you how confident they were in maths. So generally on these graphs on the left-hand side, we've got the results from before the first survey, which was just before they started their maths degree. And on the right-hand side, we've got their results after 6 months. So this was in February or March, so after the first semester. And we can see on the top bar there, so the pink color is kind of strongly agree. So we can see that the percentage of students who remain confident in maths after the first semester has dropped down. Likewise, there's a decline in this perception that maths comes naturally to them. Before they started, most of the students were reporting that they were the best at maths or among the best at maths in their school. Whereas if you look down to the bottom row, we can tells you whether they thought they were going to be among the best at their university course on the left, and then whether they still thought that after 6 months on the right. So most of these students are coming in confident in maths. They think it comes naturally to them. They're among the best in their school. Everything's going well. When they get to university, there's a kind of drop in confidence. Doesn't come naturally, and obviously far fewer of them are still perceive themselves to be among the best in the subject at their institution. Most of them, though, still feel like they're having to work hard, and in fact, a slight increase in the number of who think they're going to work hard. So we had to then kind of pull this apart, and so here we've got the percentage of students who agreed or strongly agreed to those statements, but we've broken it down by whether they reported themselves as male or female. So the confidence in maths, there's not a lot of difference between male and female students before they start. But at the end of the first semester, we can see, well, female students are probably twice as likely to drop down twice as much as the male students. So clearly the female students are suffering from a greater lack of confidence after the first semester compared to their male peers. And it's true that both at school and at university, female students are reporting that they have to work hard to do well in maths. Maybe maybe more conscientious. Maybe they're maybe it doesn't come quite so naturally. And then we kind of also break down those results by which type of university they went to. So this was data derived. We asked them what their A-level grades were as part of the survey, and so we split universities according to whether students were typically reporting and having an A star in maths, an A in maths, or grades B to E in maths at their university. So again, most students coming in confident in maths, but we can see that students who are going to the universities that require an A star in maths are suffering a greater drop in confidence than students who are going to institutions with lower entry requirements. And similarly, the ones going to the kind of the top universities with the highest entry requirements, again, they're the most confident, they're most likely to be among the best at maths in their school, but they suffer the biggest drop in that measure when it comes to their university, because they're studying amongst, equally good high-ranking mathematicians at their institution. So again, maybe there's some indication here that universities at the students at the universities with the highest entry requirements are suffering kind of the most in the kind of on this transition measure. Okay, lots to go on this graph, so I'll go through it slowly. So we asked them about how helpful do you find different ways of learning maths? And the top two bars here probably are not a huge surprise. Nearly all students find it helpful, or very helpful, to work through maths problems and exercises, or to work through past paper questions. So presumably that's experiences of A-level or other level 3 qualifications on the left, and their experiences of university on the right. And you can see there's not a huge amount of difference in how they are studying in that respect. And in fact, most of these measures, there's not a big change. There's there was the fifth one down, whole class discussions led by teacher. That's less helpful at university compared to school. And similarly, kind of group work organized by a teacher, so third one up from the bottom, has also gone down. So this kind of collaborative ways of learning are less helpful, perceived to be less helpful at university than at school. The one that's gone up most dramatically is the use of AI tools. So at school, only 13% of students were reporting the use of AI tools as a helpful way of learning mathematics. Lots of students disagreed and said, nope, that's not helpful. And a quarter of students didn't answer that question at all, which suggests to me that they just weren't using AI at all. So to answer the question in the chat, yes, so NA is they didn't answer the question. So that could be because they didn't experience it or didn't use it, or it could just be that they didn't answer that question. So yeah, we'll have to read between the lines on that one. So before, so at school, only 13% of students were finding AI tools helpful for learning mathematics, whereas if you go to university after the first semester, we can see that 58% of them are now finding AI tools helpful. So to me, that raises a question about what are we doing as lecturers to teach students how to use AI ethically and usefully, and so on. Some use of math support centers, but obviously they're not available at all universities, so that might be part of the reason for the large grey bar there. Okay, and again, if we kind of break that down by type of, by the expected first year grade. So again, we've got before university on the left, after first semester of university on the right. I pulled out here 2 questions relating to the use of technology, and how we've split it here is that the pink bars at the top are the students who report they are on track for a 70% average or higher at the end of the first year. Whereas the light pale blue bars are the students who are on track for a third-class average or lower. So before university, the kind of these stronger students and weaker academically students, we can't see much difference between them. But after the first semester, we can see that the students on track for first-class degree are more likely to be using math software to help with things like visualizing data or plotting graphs, whereas students who are on track for lower outcomes are using AI tools more than the others. So there's kind of a difference here between how academically stronger and weaker students are using technology to help with their studies. So come on to chat about how AI may be more available at university compared to school. Yeah, that's absolutely true. And obviously AI is improving all the time. So AI from a year ago is not the same as AI tools now. So, but I think it might also reflect on the fact that maybe there are fewer learning resources available at university. In terms of at A level, you've got kind of standard textbook, standard YouTube resources you can always go to. Whereas university, each module has its own resources, and maybe they're looking for AI to fill in some of the gaps. Okay, and then general learning strategies about how do they learn. So again, we've got before university on the left and after the first semester on the right. Again, not a huge amount of change in these kind of general strategies over the first 6 months of their course. So they all think they've understood if they can answer problems quickly. The second one, second most popular learning strategy is to look at the answers in the back of the book, which hasn't really changed. Third and fourth ones I find interesting because they both say that they learn maths learn a lot by explaining maths to others, but also simultaneously they learn maths best when they work on their own. So that's interesting. Maybe a contradiction. Yeah, so if they do they need an explanation from the teacher? That doesn't change a huge amount. We do see though a small increase though in the percentage of students who report that it's easier to memorize maths techniques rather than understanding them. So obviously, well, I say obviously, as a lecturer, I try to teach my students why a technique works rather than just blindly teaching them how to crank the handle and get the answer out. But maybe memorization, more students are relying on memorization maybe at university than they did at level 3 or A level. So I'm trying to read the comments in the chat at the same time as talking and failing. Okay, so let's split this down by gender. Okay, so we saw quite strong differences here in how males and females were reporting they were learning. So female students were relying more on explanations from their teacher compared to male students, and there's quite a big difference there. And also the female students were reporting, sorry, that they were finding it easier to memorize maths techniques rather than understanding them. So again, this kind of points towards female students, or the transition experience being maybe more difficult for female students than male students. And again, if we break down the results by A-level entrance requirement, sorry, just to clarify, when I say A-level maths entrance requirement for universities that are outside England, so Scotland, we kind of converted things to A-level grades. So yes, the students who are going to universities with low entry requirements were more dependent on their teacher to explain things to them at school, but that differences disappeared after 6 months of university. And students going to universities with low entry requirements are more likely to rely on memorization than understanding. And again, not much change there after 6 months. Sorry to depress you, Tony. Are we going too fast for students? That's one of the answers to one of the next questions. So I shall hand over to Katie because I think she's got the answer.
Yeah, so this was on curriculum and pedagogy. So yeah, there is one, if I find the right one, of the speed. But yeah, I mean, the first one is not surprising. They find it more difficult than at school or college, which, yeah, I think it's not surprising, but it's still, yeah, a lot of them are. Interestingly, they prefer the maths topics in general to at university than at school and college, but they prefer the teaching style at university to the teaching style. No, they prefer the teaching style at school or college more than university in general. So whilst they prefer the topics, how it's taught, they perhaps are struggling with more. And then again, there's lots here that are not surprising. So they find overwhelmingly agreement that you have to be much more precise at university. It does follow on from school or college, which was a nice finding. It wasn't one I was sure whether students would agree with or not, but they do find that university in general follows on. The attendance, so I'm going to dig into this in a while, but these are all from survey 2, whereas we did ask in survey 1, do they think at university they need to attend all the sessions to do well? And we got 92% agreement, so almost everyone thought they did. This drops to 64% agreement in survey 2, which we see here. So from having 6 months at university, they now don't think they need to attend all the sessions as much, which I think is an interesting finding that probably a lot of lecturers see. So yeah, we've now got this one about the speed. So at university, the lectures normally move on too quickly, and we've got over 50% of students agreeing. So a large proportion are finding that we're going too fast, which perhaps explains some of that, why they want to memorise. And also a lot of ideas are being given at once in a lecture. So I think it's slightly under 50% agreement, but it still is a large amount of students are saying that there's too many new ideas. So again, I think that will link with the speed that we're teaching. And then I think on the next slide, we can break it down. Yeah, so we've broken it down by gender, and you can see differences between male and female responses. So, for example, females are more likely to think they need to attend all the sessions, and that fits with, again, what we'll see with attendance. We also see that perhaps females are struggling, or the transition is harder for them than males, in the sense of the lectures being too quick and there being too many ideas. Far more students agree with those than the males. So something in that transition doesn't seem to be equal between males and females, which is something perhaps we need to look at and think of what support we can put in place to kind of try and close that gap. And then we've also got, the sort of typical A-level requirements for the universities and the differences there. So those with the higher A-level requirements are more likely to agree that they need to write more precisely. They're less likely to agree that the maths follows on from school or college. So this may be that the maths that they are experiencing is different and it is more, for example, abstract. They're also less likely to agree that they need to attend all the timetable teaching. This could be because they're becoming more independent. It could be for some other reasons also. Again, it's something interesting to get to the bottom of that, these differences, because they do seem quite compelling as it changes between the grades, those differences. Next slide. Yeah, so feedback and attendance. So feedback was really interesting of whether students had received useful feedback. So this is broken down by what the students are expecting. So their expected first year grade. So those that are expecting a higher grade are more likely to say that they found the feedback they received useful. Again, this could be that their feedback's useful, which is helping them think that they're going to do well, or the feedback has helped them give an idea what to expect. It could be that students that are performing better can interpret feedback and sort of find use from it better than the other students. There's a few options of what could be happening there. But in general, feedback was very different between the different universities, which was interesting. So the mechanisms that universities have in place in that first 6 months of the feedback, some universities didn't seem to be giving much feedback at all. Others were giving a lot of feedback. Some were giving marks, so potentially they've had exams in January, but they weren't getting any feedback with that. And again, this is all perceived feedback, so they may well be getting feedback that they're not perceiving as feedback. So yeah, there's a lot of differences in how students kind of interpret that feedback. And then, yeah, going back to attendance, so this now is what proportion of sessions they actually did attend. So we saw that some students agreed or disagreed with whether they needed to, but this is what they actually were doing. So this is broken up for their expected mark again. So students that are expecting a higher mark are more likely to attend all or almost all of the timetable sessions. And this decreases as you go down the different expected marks. Again, it's hard to know which way round it is, whether students that do well are doing well because they're attending everything, or students that do attend everything are more likely to, whether it's that way around or some mix in the middle. And I think on the next slide, we've got some of the frequent reasons students gave. And this is interesting because you can kind of see what you maybe think are acceptable reasons. So for example, not attending a session for a health reason is very acceptable, whereas perhaps for poor timekeeping, which is actually much more frequent, is a less acceptable reason. And a lot of the most frequently cited reasons were more to do with choice, so a student choosing not to attend, as opposed to some kind of barrier like a health reason or employment, but things like they don't find the session useful, so then choosing not to attend. They prefer to study on their own, they've fallen behind. They're all kind of the student choosing not to come, which is interesting. I think as a lecturer, again, it's something that you often think is true, but you can never be sure. So working out what we can do about that. Of course, if a student doesn't find a session useful and has an independent study plan in place that works for them, that's fine. I suspect that not all the students giving that reason are doing that, and they probably would benefit from the sessions if we made the sessions more beneficial for them. So yeah, really working out what's going on there would be really interesting to dig into. So we also looked at coding and programming, because obviously this is something that students do a lot less of pre-university, and then when they get to university, they're suddenly doing a lot more. So we can see that a large amount of students do think that they'll use coding after their degree, so they can kind of see the point in it, hopefully, which is nice that within that 6 months they've got there, because I think before that they maybe don't know that so much. However, the confidence in coding is still not very high. So I think it was about 30%, pre-university they were confident, and it's gone to about 39%. So it's not increased a lot, although it has slightly in that 6 months. So students still aren't that confident with coding, which is something that, given so many think that they're going to use after their degree, it would obviously be great if we could bump that up. There is enjoyment with coding though, and students see that they need it to do well in their maths degree, but yeah, they're not confident and they're not finding it easy. And then we've got coding broken down for the different A-level requirements for the institutions. So those that are at an institution with an A-star requirement are more likely to think that they'll use it after their degree. They're also more likely to enjoy coding, be confident, and find it easier. So something seems to be going well for these students in terms of coding. They may be doing it more at university. They potentially were slightly more confident to begin with. We can also see for the expected grades. So students that are expecting a higher grade are more confident with coding and computing, which again makes sense because it often makes up some of the assessments. So if you are confident with it, you probably will do better in those assessments. And perhaps just by being, your confidence overall, I guess, is helping you with that coding and computing. But again, you can see that it really does kind of gradient as the expected grades go down to the lower ones, that students really aren't feeling confident in coding and computing, which again could be affecting their overall kind of expectation for the year. So I think I'm almost towards the end. So we ask students this nature of maths, and this is something that we kind of gauge it. We can gauge how they see maths as a whole. So I won't read all of the different ones, but before they started and after they started, we didn't see a great deal of change as how they viewed maths. So for example, the first one, maths is exploring problems. The agreement stayed relatively similar. We will see in the next slide, you can dig down, and it does actually in the subgroups change slightly, which shows a bit more, but potentially this is interesting that the university is a big transition in their maths kind of life, but how they view maths as a whole doesn't seem to change drastically. There's a few, did I make a note? There's a few that change slightly more than others. So maths is about remembering and using definitions, formulas, and facts. The strongly agree there has changed. Again, not massively, but it stands out as one, and it fits with what we saw before, that students find kind of memorizing a good technique, that this is shifting how they view maths, which maybe we don't want them to view maths as memorization, just definitions, formulas, and facts. But there's lots pre that where we're seeing what we would hopefully see, that they agree maths helps us understand the world. It can help be solved in many ways, it's exploring problems. All these ones we're still getting really high agreement with. So on the next slide, we can break it up. So this is by where students are from, so whether they're an international student or a home student. And the thing that you can see there's quite big differences here. So the home students are more likely to agree both before and after they've started university that maths is using rules and equations, it's about calculations, and it's about memorizing definitions, formulas, and facts. So potentially you could think of home students have sort of a narrower view of what maths is, and they're going into university with this narrower view of maths being sort of learning these things and memorizing these things, that again potentially isn't what we want it to be. And we would maybe hope that at university it would shift and maybe start to level out, but we're not seeing that currently. And then we've also got the response by the expected first year grade. So again, you can see things that we potentially think of as the kind of this narrower view of maths that potentially is less beneficial, although it may be a strategy still to learn maths. But those that are expecting lower marks are more likely to kind of fit into this narrow view. So they're more likely to think maths is about memorizing definitions, formulas, and facts. And again, it's hard to really piece out whether they see maths as that, or that's kind of their mechanism for learning maths, because that's, maybe the lectures are going too fast, they need to just memorize a lot of things, and so maths becomes like that for them. Although we see that it's not changing drastically at university, so they kind of had this mentality pre-university and after university. So perhaps that's good. There doesn't seem to be university that's just causing that. But again, it would be something that would be nice that we could kind of remove that as time goes on again. So I'll leave my part with, again, a question for you to write, have a think about in the chat. For you, what have you seen that works in supporting the transition? So we've gone over quite a lot of the things, so there may be something that we've gone over that you thought, I've got a really good idea of what would help with that, or it might be something we've not talked about, a different problem, but something you've seen that works with the transition. So again, if people want to write it in the chat if anything springs to mind.
Cool. In the interest of time, we'll just kind of quickly wrap up, and then we can have a Q&A session if there's lots of comments, really useful comments and questions in the chat. So yeah, let's go on to those as we can. So student experience, just to quickly summarize. So we've reported a drop in mathematical confidence during the first semester. Around 90% of students say university is harder than school. Surprise, surprise. We see an increase in memorization, or at least they're reporting it's easier to memorize than it is to understand. And there's a kind of drop in the perception that attendance is not necessary to do well. At the universities with the highest entry requirements, those students are reporting a greater jump in curriculum, and they experience a greater drop in mathematical confidence. So even though they start off with stronger grades, the transition isn't necessarily easy for them. Computing and AI, so students not confident in coding prior to starting, but it does increase slightly during the first semester. There's a big increase in the reported usefulness of AI. Yeah, so they kind of have this definition of maths being about remembering using definitions, formula, and facts. It seems to be correlated with lower first year marks, and seems to be correlated with students from the UK school education system. I'll let you join any dots there that you want to join or not, as the case may be. And then on EDI, yeah, so in lots of these questions, we just saw that female students were reporting differently to male students. Now, as I think it was Katie you mentioned in the Katie Steckles that was mentioned in the chat, yeah, we don't know if this is naturally because they are having a worse experience or if they're just reporting that they're having a worse experience. Nevertheless, I think it's interesting that they are reporting they are struggling more, because even if it's not real, but they think they're struggling more, I think is useful to be aware of. We haven't reported many differences relating to socioeconomic status or ethnicity. We did look at this, but we didn't see many differences relating to these factors. That doesn't mean to say that there are no transition issues related to these factors. We know that obviously certain economic groups and certain ethnicities are underrepresented in higher education maths. So there definitely are issues to do with recruitment and retention and transition relating to those groups, but maybe it comes down to wider system factors rather than what happens with relating to learning maths. So it could be to do with being able to afford to go to university, not to do with which subject you study when you get there. Just to kind of highlight some other things we're doing coming up. So we've talked in this talk about the transition survey. We're also doing a piece of work where we're mapping BSc maths degrees in the UK. So these are, when I say map, I don't mean geographically map, I mean mapping them in terms of their curriculum and their pedagogy, their assessment and their support structures. So we often break maths degrees down into like Russell Group universities and non-Russell Group universities, but is there a more intelligent way of doing that that is more relevant to student experience? And we're also doing, as we mentioned, we're doing the cohort study. So we've currently got 8,000 students. These numbers are very rough, but roughly 100 schools, 40 colleges, 8,000 A-level maths pupils were surveying them this year about their attitudes to maths in year 12. We'll follow them up again in year 13. We'll be asking them about why they're choosing to do maths or not at university. So there should be some reports coming out over the next few months, which if you're interested in higher education maths, hopefully will be of interest to you. So the transition work reported today will be coming out probably the week after next. The higher education landscape map will report that in June, and the year 12 lessons will be in September. And then for the 3 years after that, we don't quite know what's going to happen, but we need to somehow track university maths students over 3 years in 70 universities. If you'd like to work with us to achieve that, please let us know, because it would be really helpful to have some boots on the ground around the country. Great, that's all we had to say. We've got a few minutes left for comments, questions.
Okay, yes, thanks very much. Give a round of applause. If you want to give a reaction in the, there's a react button. You can do claps like that. We do have quite a few questions. I don't know if we've got time for all of them. I mean, are you two happy to go on past 3 o'clock? Because we can.
Yeah.
If people have to leave, then there will be a recording available as soon as we can do that. So I'm quite happy because there was an awful lot there. I mean,
yes. Sorry,
no, that's fine. I mean, there's plenty to chew on. I mean, that's so. Shall I just pick some questions?
Go for it.
There was one which I don't know if I missed this one as well. It says from Josh was this survey only BSc/M maths degrees, or did it include combined courses with a large math focus?
It was any course where maths or mathematical sciences comprised at least 50% of the curriculum. So joint honours maths courses, stats, and something would be in there as well. So it's not just straight maths or mathematical sciences.
Right, and another question that I was particularly interested in the answer from Matthew. Do you have a breakdown of the teachers move on to new maths too quickly question by university entrance requirement / asking grade?
We do. The question is whether I can find it in the time that I've got available to.
Was it on the slide? I can't remember.
Let me.
Because I mean, there were a number of crucial things, sort of like very interesting things where you think, oh well, perhaps we can make a difference here. You know, it's
so it was about moving on too quickly, wasn't it?
Yeah.
So ask me another question while I find this one.
Oh yeah, I can try and answer something.
Right, okay. How accurate are students with regards to predicting their grades? Is there any data on this? That's from Lawrence.
No, it's a good question, and it's something that I think when we use that, we need to be very aware that it gives us an idea of what they're predicting, and we hope that by the 6-month mark, a lot of them will have had marks that they'll use to be kind of predicting, but it's going to be very susceptible to their confidence, and things like that. So yeah, it's by no means perfect, but it gives us an idea.
Okay, thanks. Chris, did you mention? Oh, you have found something.
Yes, I don't know if you can see this.
Yeah.
Is this what you wanted, Matthew? So reporting whether they move on too quickly in lectures or contain too many ideas by the type of university entrance requirement. Is that what the question was asking for?
Yeah, breaking it down by entrance requirements,
yeah.
asking grade. So it is in there.
So it's in there. There isn't a huge amount of difference, if I'm honest, which is why I didn't put it in the slides. I mean, there is a difference by whether they think they need to attend the teaching sessions, and whether they think the curriculum follows on from school, but they're not a huge amount about whether the pace of learning is too fast or too slow. So maybe each university's got it about right, if half of students think it's moving on too quickly and half of them don't.
Right. Okay.
So you can a sneak preview of the report there.
Yeah, well, looking forward to it, seeing the whole thing. Maybe you answered this, and I was too busy trying to write things in the chat. But what's the follow-up on this? Are you going to check them next year or send out to the same people? Are you going to do that? Or?
That's an open question. Yeah, well, so we did incentivize them to take part in this survey. So there's a question about whether we go back to them again next year and follow this cohort of students all the way through second year, third year, or do we, we've got our 8,000 A-level maths students at the moment. Do we follow them through and repeat the survey again in 2 years' time when they get to university, when we have a bit more of a track record about their A-level experiences as well, so we can relate transitions back to A-level experiences as well. So there's different ways that we could go from here. Yeah, it's to be decided.
Yeah, right. Because I mean, both would be great, but I mean, I think I'd prefer to see one that was longitudinal, so you just follow the cohort through. I think that would be, that would be quite eye-opening. See what happens by the time they get to the third year. Yeah. Okay, so I've got another question here. Can you say something about the overlap between women and those with the B to E grades? As you said, A-level performances did differ by gender. To help understand which or both factors are more relevant when you are observing clear differences between men/women and also simultaneously A*/BE.
That's a very good question. One we need to do more analysis on. So so in many respects, I think David Hodge also mentioned this in the chat. The responses from female students and the responses from those who go to university with grades B to E are kind of aligned with each other, but they're not necessarily. I don't think they are necessarily the same students, because I don't think there's a greater proportion of female students at universities with low entry requirements. So I think both of these things are true, or at least reported. both these groups of students reported that these things are true. I don't know. I mean, Katie is my expert on male-female differences, so I don't know if you've got any thoughts.
Yeah, I feel like I should have a look just at the actual, and I can't remember. I feel like we probably did, but I've definitely not got the graph to hand now of the split to double check that it's not massively biased towards female in one. Like you say, Chris, I don't think it is. So I think it is just a similarity between those groups of students rather than them being the same pool of students. I guess it could potentially link with things like their confidence, and they're sharing those characteristics. But yeah, I will double check my table to make sure that they are not just all females are in one group, which I'm almost certain they're not, but I will double check.
I mean, it should also be said, I guess, that there are fewer students at universities with lower entry requirements, because the big universities all have high entry requirements. So you have to bear that in mind as well.
You have to go down quite far when it however, I mean, there are differences when you get to the top end. If you're looking at the A stars, the top university departments have very poor intake of UK female students. I think that needs a bit more work. But I mean, there's sort of like things I've looked up about that, and the things I've looked into. That's definitely the case. But yeah, when you get down to B's and E's, I don't know. Okay, so shall we just continue? We've got a few more questions. So, got a question from one of my colleagues, Phil. How much can the increased reliance of female students on direct instruction be attributed to, or at least relates to, their relatively low stated levels of confidence? I mean, do you have any thoughts on that?
Yeah, and I guess we didn't ask them why they gave the answers that they did. Katie, do you have any thoughts?
I mean, we do have some like free text responses that we haven't looked at yet. That long term will be, because that's sort of how they found the transition. That again, I think that may illuminate some of the why. I'm just trying to find the question because I feel like there was a lot in it, so I don't want to miss.
Would you want to repeat the question? Is that?
Yes, please. Yeah.
All right. Okay. How much can the increased reliance of female students on direct instruction be attributed to, or at least relates to, their relatively lower stated levels of confidence?
Yeah, I guess like Chris said, it would just be me hypothesizing at this point. That we've not got the data to say. Again, it's an interesting point to think about there, and think again in our future, whoever we are looking at, because at some point we are going to be coming back to look at this, whether that's something we can kind of try and pick out better.
Right. Okay. So moving on to another one. There's from Jonathan. Are there similar transition surveys for other subjects, such as history, geography, biology, and so on? Do you know of other things?
Not that's in the same way that we've done it. Yeah. But yeah. If somebody wants to set up an observatory for historical education, we'll happily talk to them.
Yeah, so I thought about the knock in student confidence in the way it goes down pretty rapidly after 6 months. It would be interesting to see what happens in other subjects, whether that is something that just happens in universities, or is it?
Well, I think it must happen in all subjects to some extent, because you go from a very small, well, typically from a small classroom environment where you're the top dog in your subject, and you get to a university, particularly if it's a high-ranking university, and then you're surrounded by 200 other people who are equally smart as you. You probably do suffer a drop in confidence, irrespective of subject. Would be my guess.
Okay, so there's a question from Nick, which is, do you know if they took only maths or also further maths at A level? Any differences in answers by this factor? And then Chris will know that I'm particularly interested in further maths. So
okay, so we did record further maths grades and whether or not they'd done further maths. Those results. So we could have presented the results by A-level maths grade, by A-level further maths grades, or by the type of university they went to. All those three things are all highly correlated with each other, so we haven't shown all three of them because they're effectively measuring the same thing. I didn't see, well, again, maybe Katie and I need to go back through the data again, but I didn't see anything that was specifically obvious where further maths helps in a way that goes beyond just being good at maths helps. If that makes sense.
Yeah, I think that's why sort of we didn't pick those out, is that they weren't showing a lot. And again, in some of the free text stuff, again, this is just from me reading through them. I think that didn't seem to be picked out. I think students maybe thought it would come out more, and it didn't seem to.
Yeah, so it seems as though further maths isn't really helping, and it may indeed be putting people off going to university, because it looks like you need to be an absolute genius to get into a top university to study maths, because you need further maths, you need your step papers and everything.
Yeah, we also recorded how many of them had step or mat or TMU or the other entry additional exams as well.
Yeah, but I think that's something for another day.
Yeah.
Okay, well, I've got last couple of questions. Lawrence, is it really surprising that the best in class at school doesn't automatically correlate with the best in class at university? And then put in brackets, after all, best sports team in the country doesn't automatically imply best sports team in the world.
Yeah. Obviously, if you're the best at school, it doesn't mean you're going to be the best at university. It's just was more kind of like just from the perception of the individual. You know, some people have their identity in being the best in their class or something like that, and that's part of their identity. That's part of their sense of belonging. So it's just obviously, if you then go to an environment where that's no longer the case, then it shakes your identity and your sense of belonging. Maybe I'm not a mathematician after all.
Yeah. Katie, do you have anything on
I remember as an undergrad in one of my first lectures them saying, put your hand up if you were the best at school, and almost everyone put the hand up, and then kind of being like, you can't all be the best in here when there's 200. And that always stayed with me. So I think, yeah, it's not at all surprising, and I guess it's about trying to get students to be okay with that they don't need to be the best to still be good enough. Because yeah, I think like Chris says, it can knock people's confidence if they put so much weight on that. But really, they shouldn't. They're still doing really well.
Right. Yeah. Okay. Shall we have one last question? I think it's about the memorization, which I think is something where we could do something about transitions, I think. So can you talk about whether changes in methods of assessment have been considered / recommended in relation to the memorization issue? It seems like students thinking maths is about memorization is a natural consequence of solely assessing them based on what they can remember in a closed exam setting. Do you have any thoughts on that? I mean, it's I think slightly removed from what you're doing. I think maybe it's the next stage, isn't it?
Yeah, I mean, I guess my only thought is they put a great weight on past papers which have obviously closed book, short answer, typically questions, which is how they're drilled at A level or equivalent. But they also talk about maths being creative and being able to solve problems in the real world, and being exploratory, and there being lots of ways to solve problems. And so the way that their responses, which I think are a result of how they've been assessed up to 18, and their view of maths are kind of quite different. So I guess at university then, when we open up the variety of assessment methods, maybe not in the first semester, maybe the first semester is still quite, because of large class sizes at some universities, still exam heavy. But yeah, maybe there's a variety of assessment techniques, and of course for some assessment techniques you don't need to memorize stuff because they're presentations or open book assessments. So it'd be interesting to see as they go through the university and as they experience more open-ended assessment types, whether their thoughts on memorization change. Is my only thought.
I think as lecturers as well, there's a lot, like when we're asking them to memorize something, we really need to think why. So I teach first year statistics, and I'm quite keen on being like, they've got a formula sheet they still need to know how to use all the formulas, but I don't want them to spend their time memorizing it because I don't do that. And again, I think someone put it in the chat about if they are using AI and they think it's just memorization, then surely there's a worry that AI will just take our job. So really we need to think like, what is it that as mathematicians we're bringing that a computer AI can't bring, and it's that understanding. So I think as lecturers we really need to think of how we're examining, and if we are just asking them to memorize stuff, that's not giving them a good idea, and we're testing skills that actually do we memorize things, or can we just Google it if we've forgotten it. So I think it's something we need to think about, and also it won't help with them how they think about maths if we're just asking them to memorize, because they've not got time to understand. So yeah, I think that's something as lecturers we can, and probably are, but keep thinking continually, like, why do they need to memorize it? And if there's not a good answer, scrap that. There can be a formula sheet, something else.
Sometimes memorization is helpful, right? If you memorize something, then you can use it, and it helps with fluency, and you can use your brain power to focus on the more difficult concepts rather than having to look up the definition of something easy. So it's not necessarily a bad thing to memorize stuff. It's just when they memorize without understanding, that makes me feel uneasy.
Because I think also sometimes you memorize something because you just have used it so much. So again, you're not memorizing it for memorize sake, but just you use it so quickly that you don't want to have to keep going back. So I think it's definitely fine to sometimes say, actually, you do need to. It's just as lecturers, we need to ask ourselves why, and we need to have an answer for why that's good enough, and that answer exists, but not always.
My son's in year 4 and he's been drilled on his times tables because he's got to do the year 4 times tables test. So for him, multiplication is just memorizing a list of yeah, multiplications, which is useful. Like when he gets onto harder problems, he'll be able to know these facts by recall. But yeah, if he doesn't understand why 3 times 6 is 18, then yeah, what's he gained?
Yeah, indeed. Well, that is the final question. So I'd just like to say thank you very much for doing this, and thank you very much for going slightly over. But I thought it was very interesting stuff, and I thought, I mean, there's so much to get into. It's going to be great to see the report. And so if people could just maybe do claps with their online reaction things. And thanks to Chris and Katie for a great talk. As I say, I mean, there's an awful lot there. So
yeah, feel free to get in touch
good.
with us if you've got any questions, comments afterwards, and we'll try and get back to you.
Okay, and thanks to everybody for coming. And don't forget, there will be another Talmo on, I've forgotten which day. I should really look it up, shouldn't I? Wednesday, 18th of June. We're going to have their final thing. So thanks to everybody, and see you all next time.